Today we'll be modifying an Ajazz K620T mechanical keyboard. The Ajazz K620T is a 60% Bluetooth compatible mechanical keyboard that ran on Kickstarter earlier this year. It can still be purchased via the Ephomaker website for $75 USD. What makes this board unique is the groove at the top of the case, which can be used to support your smartphone or tablet that can connect wirelessly to the keyboard via Bluetooth. There is also a volume knob at the top left corner which adds some extra functionality. At this stage there is no ability to reprogram this. The keyboard comes with die-sub PBT keycaps that are actually of a reasonable quality considering the price of the keyboard. There was no obvious warpage to the keycaps. Legends were crisp and the keycaps themselves were decently thick. Today we are looking at the white case with white keycaps. There is also a black case that comes with black keycaps. Disassembly was fairly straightforward. There are two Phillips head screws on the front of the case that need to be removed. The knob also needs to be removed. To do this, I used a keycap puller. It was attached quite snugly. Next, the top and bottom case need to be separated. They are held together via plastic clips, which are a bit finicky to say the least. I used a combination of guitar picks and plastic cards to pry the case open. Tay Keyboards has a video where he modifies one of these keyboards and he makes it look a lot easier than I did. I will link his video below. Once the top case is removed, you will need to remove a nut and washer from the knob assembly to allow the plate and PCB assembly to be removed. Be careful when you lift up the PCB and plate, because there is a ribbon cable that connects the main PCB to the daughter board for the knob and USB-C port. You don't want to break this. There is a plastic clip that holds the ribbon cable in place. I used a flathead screwdriver to gently lift this up to allow removal of the ribbon cable. It's a bit hard to show it here on camera, but just make sure you're careful and you'll be fine. Now we can move on to desoldering the switches. Desoldering pre-built keyboards can often be tricky. I used a Hacker FR301 desoldering gun, which certainly made the job a lot easier. You can get away with a desoldering pump though. I recommend the Engineer SS02 solder sucker. Be careful what temperature you use to desolder and make sure not to spend too long heating the pads. Sometimes you will find you will not get a clean desolder. Note that I was unable to remove two of the switches here. Often pre-built boards are soldered with lead-free solder. This requires a higher temperature to desolder. Reflowing these joints with leaded solder can help you get a clean desolder. Be careful when removing the switches. Basically, if they are hard to remove, don't force it as you may damage the PCB. Try reflowing the joint and desoldering again. Now that we have the switches desoldered, we can move on to modifying them to improve the sound and feel. Lubing switches is tedious, but is definitely worth the time spent to do it. First we need to open each switch and separate it into its parts. The easiest way to do this is using a switch opener. Some of these switches were actually quite tricky to open, as you can see here. This board was built with Ajazz's own pink linear switches. You can also purchase it with clicky switches if you prefer. The pink switches were very scratchy and didn't sound fantastic stock. I like to tub lube my springs using Krytox 105. This particular bottle was purchased from Switchkeys. A little goes a long way. I reuse this tub every time I lube springs, so there is never any oil wasted. I find I am able to get a nice consistent coating on each spring using this method. You can also bag lube the springs if you prefer. The results should be exactly the same, just give it a really good shake. For linear switches, I like to use Krytox 205G0 to lube the housing and stems. Huge thanks to All Caps Keyboard Accessories for supplying the Krytox 205G0 used in this build. Start by dipping your brush in the lube and wiping most of the excess off. I like to wipe each side of the brush 3 times. You should be able to see a light transparent coat of lube on the housing, but not huge globs of lube. Make sure to lube the rails and the inside of the bottom housing. I do not typically lube the leaf of linear switches. Next, apply the switch films. I use Deskeys films here. Switch films help to improve the housing tolerances, therefore reducing wobble. They also help deepen the sound. Some switches benefit from filming more than others. The next step is lubing the stem. Make sure to apply a thin, even coating to each side of the stem that contacts the housing. Then carefully place the stem on top of the spring. Make sure the legs are facing towards the leaf. Finally, lube the top housing where the stem makes contact as shown here. This helps reduce the sound of the upstroke when typing. And now repeat this process 60 more times. Using a lube station like I did here will help streamline the process, but is not necessary. I did end up using a bit more lube on these switches than I showed previously. I noticed that it was still a bit scratchy after lubing. It is always a good idea to test your lube job before moving on to do the whole batch, so adjustments can be made if necessary. What works for one switch may need to be adjusted for a different switch. The next step is to tune the stabilisers. These stabs are clip-in stabs. I strongly recommend swapping them out for GMK clip-in stabs if you can, as it will greatly improve the final outcome. These stabs were interesting. The wires were only very sparsely lubed, but I still made sure to wipe this off. They did not need to be clipped. Again, using Krytox 205G0, I lubed the inside of the housing and the outside of the slider. It is still important not to use too much lube here, as it can lead to the stabilisers being sluggish. the wire, I like to use dielectric grease. Apply this to where the wire goes into the housing and slider. I am normally quite generous with this, but it is possible to use too much. You can always add more if needed. Next, put the stabilisers back in the plate and start putting the switches back in. The PCB only supports 3-pin switches, so I found it easiest to solder in the corner switches and make sure they were well seated and flush with the PCB prior to inserting the remainder of the switches. I started by soldering 1 pin per switch while pushing down gently on the PCB. I then heated that joint back up while applying downward pressure to make sure that the switch was well seated before soldering the second pin. Sometimes when inserting switches back into the PCB, you may encounter a bent pin. This is easily fixed by using some tweezers to gently bend the pin back. It doesn't mean you need to throw the switch out. Once all the switches are inserted, we can move on to soldering. Here I am using a 6040 rosin core leaded solder. And finally, we can reassemble the board. Again, be careful with the ribbon cable and otherwise just do everything in reverse order. And now what you've all been waiting for, the typing test.